Marcus Chown is here with us tonight after travelling from his home in London via a few days in Australia.
Yep.
A bit sleep deprived, I understand.
A bit.
Marcus is a former radio astronomer who is now cosmology consultant for New Scientist magazine and author of 12 books, I think we counted, including We Need to Talk About Kelvin, which was shortlisted for the Royal Society's Science Book Prize in 2010, the very reassuring Quantum Theory Cannot Hurt You, a much-acclaimed children's book, Felicity Frobisher and the Three-Headed Aldebaran Dust Devil, and his latest book, What a Wonderful World, one man's attempt to explain the big stuff. And I do highly recommend it. It actually made me understand things that I didn't know I didn't understand.
Oh, that's good.
Marcus is also a prolific tweeter. He's just been named the 5th most influential person over 50 on Twitter.
In Britain.
He's the winner of a Digital Innovation Award for the wonderful Solar System app, and he's an occasional stand-up comedian. Among Marcus's many awards and accolades, he also has the distinction of being recipient of the much-coveted Smartest, Sexiest Silver Fox Award. And that was after his 2009 appearance at the Auckland Writers and Readers Festival, so congratulations for that one.
I should dye my hair, maybe.
So the advertising for this event actually promised that in this 1-hour session, Marcus would reveal the secrets to life, the universe, and everything. So are you ready for that?
It seems a bit daunting.
It is daunting. But I thought we'd start with the universe, because that's really where you started yourself. Yeah. You started as a radio astronomer. What does that involve?
I worked in California at the Caltech, California Institute of Technology, and I was involved with very long baseline interferometry. And this is where you use radio dishes in Europe and America and Australia, and you use them to look at the same object all at the same time, the same galaxy, the same quasar, and you record the signals, and you fly them together, and you combine them on a computer, and you effectively get a telescope as big as the Earth. Mm. And the bigger the telescope, the finer the detail, the more you can zoom in on these objects. So that's what I did.
With the radio astronomy, are you looking or are you listening?
Well, you're looking, but of course, if you were to, wire up your receiver to a loudspeaker, you could be listening, because really what you're picking up is radio static, the static that you hear if you tune the radio station between the channels. Yeah.
And so you moved from that into writing. How did you make that transition?
Well, when I was at school in England, I really liked writing. I really liked writing imaginative things. I liked English, and I liked science. And I don't know what it's like in New Zealand schools, but in England, they wouldn't let me do both. You know, you couldn't do arts and sciences. So I ended up doing physics at university in London and then astrophysics in California. But I still liked writing, and I used to write stories and things. And then when I was doing my PhD in California, I wrote to newspapers in England and said, "Can you give me a job?" Mm. And that's how I'm very risk averse. So I thought, since I was doing science, if I did science writing, at least someone would pay me.
Right. Sorry?
And then, I worked on New Scientist for a few years. I was their book editor, which is the most fantastic job in the world. It's Christmas Day every day. You get all these parcels full of books. And then you get to meet all the authors that you really, really want to meet by getting them to do reviews. So I used to get people like Doris Lessing and Terry Jones and Monty Python, all these kind of people. And then I was the science news editor for a while. And I did about 4 pages in the magazine of news items on science, which I commissioned people to do. And then my wife, who's a nurse, got a job out of London in Worcestershire, which is in the centre of England. And so I thought, I'll leave New Scientist and I'll go freelance and just write books. So again, I'm risk averse, rather than writing, risky novels or something, I went to popular science books where someone would pay me in advance.
Oh, really? And a lot of those first books that you wrote did draw on your expertise and knowledge in cosmology and astronomy and physics.
Yeah, my first popular science book was called Afterglow of Creation, which was about the afterglow of the Big Bang, which is in this room at this moment, actually. Incredibly, 99.9% of the photons, these are particles of light in the universe, are tied up in the afterglow of the Big Bang, and only 0.1% are in the light of stars and galaxies, you know. But I kind of knew a bit about this because I was at Queen Mary College, which was in London, and one of the research teams had tried to measure the afterglow of the Big Bang. It's the coldest thing in the universe, the most difficult thing to measure. They tried to measure it from Concorde, because Concorde goes above a lot of the atmosphere, and water vapor in the atmosphere emits microwaves like the microwave background, and so you need to get above it. And they accidentally measured the temperature of their mylar window in their experiment. And this is really the way it is with these kind of experiments. People end up measuring the temperature of their balloon, the cables. It's just as, so I knew that this was a really difficult problem, because to see the coldest thing in the universe, you've got to subtract all the hot things. So I knew something about it. Well, it all came about because in 1992, a satellite called COBE, the Cosmic Background Explorer, had noticed that this heat radiation left over from the Big Bang, which is all over the sky, varied slightly in temperature. And these temperature fluctuations were the seeds of galaxies in the early universe. And I think Stephen Hawking said something, this is the greatest discovery of all time. And one of the researchers said, we have seen the face of God. And it was in all the newspapers, you know, and Archbishop of Canterbury was discussing it and everything. So I wrote to publishers and said, I could do something about this. And they all wrote back and said they weren't interested, except one publisher. So that's how it got going.
Right.
But I didn't actually know about this experiment, this space probe. So I had to identify people in America to go and talk to find out about it. And I didn't tell anyone at New Scientist that I was writing this book. And I went off for a week and talked to all these people, and then I couldn't even finish my book for the deadline, so I had to pretend I had a bad back. And the terrible thing was, the editor of New Scientist was so nice, he was so sympathetic, he sent me all these books on bad backs. And he didn't realise I was just doing it so I could finish my book. So that was Afterglow of Creation.
So you just mentioned Stephen Hawking there. And it reminds me that in several of your books you talk about black holes and how they work. Now, Stephen Hawking has just come out and said that perhaps they don't exist at all. So does that mess with the whole cosmological worldview?
That's very, very interesting. I mean, Hawking, this is the second time that Hawking has claimed that black holes are not black. He did it in the 70s when he realised that quantum effects around black holes would create this stuff called Hawking radiation, which would flood out from a black hole and would sap a black hole of energy, and eventually the black hole would evaporate. So Hawking, incredibly, showed that black holes, which we normally think of as objects whose gravity is so strong, nothing, not even light, can escape, that black holes are not black. And yeah, absolutely. In the last couple of months, he's published a paper claiming that they don't quite exist. And it's all to do with the Hawking radiation, because what the Hawking radiation tells you is that gradually the energy of the black hole is sapped away, and eventually the black hole evaporates and disappears. So black holes tend to form, or many of them form, from the shrinkage of massive stars that come to the end of their lives and shrink catastrophically under their own gravity. But if a black hole forms when that happens, but eventually evaporates and there's nothing left, then the question is, where did the information that described the star that made the black hole go to? You know, it's vanished. It's a law of nature that information cannot be destroyed. And this is called the black hole information paradox. And I won't go into technical details, but it's trying to address the black hole information paradox that's led Hawking to say that the horizon around a black hole, which is kind of the imaginary surface, the point of no return for infalling matter, may not be what we think it is, and it might be possible for stuff to leak out of a black hole. But I've talked to people who know about the black hole information paradox, and they say they can't really tell from Hawking's paper whether he's right, because it's only about 3 pages long.
Is it because even they don't understand him?
Yeah, I mean, oddly enough, I know Brian May of Queen because he did astrophysics like me, and he finished his PhD recently. And Hawking went to a showing of We Will Rock You, Brian May and Queen's rock musical recently, and Brian May got the chance to have dinner with Hawking, but it did take, in 3 hours, Hawking was only able to assemble a few sentences because it takes so long to assemble sentences.
And another of the things that you talk about in a few of your books is the idea of a multiverse. Can you talk about that? It's quite a hard concept to get to grips with.
Yeah. Well, maybe I'll go backwards and say that the word universe keeps changing its meaning. You know, if 300 years ago the universe would have been the sun and 6 naked-eyed planets, then at the beginning of the 20th century, the universe meant the Milky Way, which you see incredibly well in the southern hemisphere, much better than we do in the northern hemisphere. And this band, misty band, across the sky, Galileo was able to show with his first telescope, was made of stars. And so the universe then was this flat disk of stars of which the sun was a part. And then it was discovered by Edwin Hubble, an American astronomer, that in fact this band of stars is just one island of stars, one galaxy among 100 billion other galaxies. It looks today as if the universe is growing again, and our position in it, you know, we're shrinking even more because nature appears to be banging us over the head from many, many different directions and telling us that there is more than this universe. In a trivial way, we know that's true because our universe is surrounded by a horizon. I mean, basically, the universe was born about 14 billion years ago, and what that means is we can only see the objects, we can only see the galaxies and stars whose light has taken less than 14 billion years to get here. Objects whose light would take 15 billion years to get here, its light hasn't arrived yet. So because of that, we have this horizon around the universe beyond which we cannot see, and we call everything within the horizon the observable universe. But we know there's more over the horizon, just like we know there's more over the horizon at sea, you know. And if we wait another billion years, a lot more stuff will come over the horizon. How much is there over the horizon? Well, according to the standard picture, which is called inflation, there's an infinite amount of universe beyond the horizon. The universe is effectively infinite. So if you think of our little bubble as 100 billion galaxies, then there's an infinite number of other bubbles beyond. So that's one version of the multiverse. But there are lots of other things that tell us that there may be more than one universe. One is the fine-tuning or apparent fine-tuning of the laws of physics. If we look, for instance, at the strength of gravity, if gravity were maybe 2% stronger than it is, then the material at the center of the sun would be compressed and more than it is, and it would be heated more than it is. And nuclear reactions at the center of the sun are amazingly sensitive to temperature. So they would be much faster, and the sun would burn all of its fuel in far less than a billion years. So there wouldn't be time for the evolution of intelligent life like us, which has taken about nearly 4 billion years. If, on the other hand, the force of gravity were a few percent weaker, then the material at the center of the sun wouldn't be compressed enough to ignite the nuclear reactions that power the sun. And wherever you look in nature, if you change anything by 1 or 2%, if you change the strength of the nuclear forces, if you change the mass of the electron, you find that you don't get a universe that leads to with stars and planets and, you know, a life. So, you know, what are we to make of this? I mean, either God fine-tuned the universe for us to be here, or maybe there is a multiverse. So there are other domains of the universe where gravity is stronger or weaker, and we've arisen in the universe where the forces and the masses are okay for stars and, you know, and planets and us. Because how could we not? So that's one version. So there's a lot. This is an emerging worldview. So I can't tell you definitively what the multiverse is. I mean, there appear to be lots of different multiverses, and we don't know how all these ideas mesh. But it does appear that we're on the verge of yet another expansion of the universe, and we're going to shrink even smaller as human beings in this vast universe.
What about the idea that the universe as we know it is a hologram that's projected from one side of the universe? That's one I find. You have asked me a really complicated thing. And does that fit in with those theories, or is that another completely different idea? That's completely different. But again, this comes back to black holes and the black hole information paradox. A star shrinks to a singularity
which is basically nothing, leaves behind this horizon, becomes a black hole. And one suggestion is where the information, well, where does the black hole radiates Hawking radiation and evaporates. And one suggestion, and it's founded in something like string theory, is that the information that encoded the star is actually encoded in the horizon. So if we would look at the horizon around the black hole, we would find on the microscopic scale it's like a mountain range, so all the information. So as the Hawking radiation is radiated into the universe, it's modulated in the way that we modulate a radio signal from a radio station with a voice. And so the information is returned to the universe. But what that means, if the information that describes that star is encoded in a three-dimensional star, is encoded in a two-dimensional surface, that's like a hologram. So if you've got a credit card, there is a three-dimensional object that is encoded in a two-dimensional surface. So people then said, well, actually the universe is like the inside of a black hole. We have this horizon, this point from which we can't see beyond around it. Maybe the information that describes the universe is encoded in the horizon around the universe. And so we are, in some sense, a projection, a three-dimensional projection of a two-dimensional reality. Now that's quite controversial, but it does appear that the universe or the laws of physics require one less dimension than we need, than we see. So it's a bizarre idea. Do you mind being a hologram?
Well, sometimes I find it quite reassuring. Yeah.
Well, you're the first person I've met who's reassured by being a hologram.
It can be calming. But with those sort of out there ideas that are actually quite hard to grasp, are those ideas just come to mathematically, or do physicists genuinely believe that these are true? I mean, is there a chance of testing those hypotheses and finding evidence for them?
When you're talking about the universe, you have a basic fundamental problem. In science, you do experiments and they are repeatable. So, you can test something and then someone else can check it. The big problem with the universe is, of course, there's only one universe and you can't do experiments. So in some sense, it's not as easy to speculate about cosmology, So there is a lot of speculation which is wild.
Yeah.
But there are a lot of things that we know. I mean, for instance, we know we know that the universe began in a hot, dense phase. We know that because the afterglow, as I said, of the Big Bang is all around us. If you tune a television between the stations, it's got to be an analog television. 1% of that static has come directly from the Big Bang. Before it was picked up by your TV aerial, it had been traveling for 14 billion years across space. And the universe is expanding. The galaxies are flying apart from each other like pieces of cosmic shrapnel. And so we can run that expansion backwards like a movie in reverse, and we come to a time when everything was compressed 40 million years ago. And sure enough, when you compress something, you make it hot, which explains this heat afterglow. So we're pretty certain that happened. But then the Big Bang model contradicts what we see in three major ways. One, it says that the expansion, these bits of cosmic shrapnel flying out, well, it's going to be slowed down because there's gravity operating between all the galaxies. It's like there's a web of elastic connecting all the galaxies, so it should be slowed down. What do we find? In 1998, it was discovered that the expansion is speeding up. So we've had to postulate that about 73% of the universe is this invisible stuff that fills all of space and has got repulsive gravity. And it's called dark energy, and its repulsive gravity is speeding up the expansion of the universe. So we bolt that on. That's probably more speculative. Then for instance, the Big Bang model contradicts me and you sitting here, because out of the cooling debris of the Big Bang, there form galaxies. And those galaxies form as gravity enhances density. So there's a slight place where there's slightly more matter than the rest. It's got slightly more gravity. It drags in more material. Its gravity gets stronger. It's kind of like a process like the rich getting richer, And that's how the galaxies are formed. However, you need about 10 times longer than the age of the universe to build galaxies as big as our Milky Way. So people say, oh, right, well, there must be a lot more matter in the universe, There's got to be 6 or 7 times as much matter in the universe as we can see. and most of it is dark. It doesn't give out. So we have to tag that on to the Big Bang as well. We have to tag on something called inflation as well. So these things are not as well founded as the original Big Bang idea. You know, it's incontrovertible that the universe began in a hot, dense phase because we have the evidence all around us. These other things that have been tagged on are far more speculative. Yeah. But I would say, as one last thing, I would say it's incredibly surprising and quite shocking after 350 years to science to discover that everything that we've been studying is only 4% of what there is. You know, that the matter, the atoms, the stuff that's made of atoms, that's you and me, all of us, the stars, the galaxies and planets, 4% of what there is. 73% is this dark energy, and 23% is dark matter. I hope that all adds up to 100%. But anyway, so from this and of the 4% of the universe that is made of atoms, we've only seen only seen half. So we've only seen 2%. The rest we think, it might be kind of cold gas between the galaxies or something like that. So on the basis of 2% that we've seen, we've erected this great edifice of cosmology. I mean, imagine if Darwin only knew about frogs, and he didn't know about insects or trees, and he had to speculate on a theory of life. That's the kind of, it's incredible. I'll just tell you one thing about dark energy, I'll just finish, that quantum theory is a very, very best description of the microscopic world of atoms and their constituents, and it's given us lasers and computers and nuclear reactors. It explains why this stage is solid, why the sun shines. It's really, really successful. When we use it to predict the energy of empty space, the energy of the vacuum, the energy of the dark energy, we get a number which is 1 followed by 120 zeros bigger than what we observe. That's the biggest discrepancy between a prediction and an observation in the history of science. So I think there might be something wrong there.
But what can we do? Can we study dark energy and dark matter, or is it all theoretical?
The evidence is observational. It's very, very difficult. We didn't notice dark energy because it's really amazing stuff. It's got some incredible properties. Like if you double its energy, you get twice as much. You know, imagine if I had banknotes and I between my hand and I pulled my hands twice as far apart and I got twice as many banknotes. That's the way it behaves. And when you've got twice as much of this dark stuff, it's got twice as much repulsion. And it's only when you get a lot of it, like it's on cosmological scales, like huge scales, that the repulsion is big enough to see. This is why we didn't notice it until 1998. The dark energy is in this room, but its repulsion is so small, you need more and more of it to get more and more repulsion. So we know the other incredible thing about the dark energy is that it's switched on. It switched on relatively recently. So we look back and we reckon it switched on 10 billion years ago, something like that. Mm-hmm. So all we can do is try and, there are kind of different ideas about what the dark energy is. All we can do is look at distant galaxies and see how they're moving and try and distinguish between these different models. But it's not possible to study the stuff, even though it's in this room. Even though the dark matter's in this room, it's not possible to study it because, it's just too weak.
Yeah. In the column I write for the listener, sometimes I invite readers to send in questions, and by far the majority of the questions are about the universe, dark matter, dark energy, cosmology. Why do you think people are so interested in these topics?
Well, I think this goes back to science teaching and things like that. I mean, I don't know. In England, I don't think a lot of people get good science teaching, and they get switched off. But when you actually tell them that ultimately science is about origins, you know, it's about where did we come from, where did the Earth come from, where did the universe come from, they get quite excited. You know, most people have not been so switched off that they aren't excited by that. And I think, you know, the thing about the universe is how incredible is it? I mean, we can see to the edge of the observable universe. How amazing is that? You know, we can see to the horizon. We can see the content of the universe, which is 100 billion galaxies like our Milky Way. Not only can we see the extent and content of the universe, but we, as I said, we have this idea that it all burst into being in this fireball 13.82 billion years ago, and out of the cooling debris of congealed galaxies. And this is a picture that previous generations would have killed for, to have this picture of where we are. And no generation has ever had this picture. And having this picture, we can then begin to ask even more questions. We can say, what was the Big Bang? What drove the Big Bang? What happened before the Big Bang? Why is there something rather than nothing? These are fundamental questions, and have a good chance of answering them within the next 10, 15 years. This is a fantastic time to be alive.
Yeah.
If you're into science.
So one of your recent books is called Tweeting the Universe, and it consists of 140 character statements about the universe. So was that a fun book to work on?
Yeah, I normally come up with my ideas for books myself. But I have a friend called Hovert Schilling that I met, actually, on Aruba, which is a Dutch island in the Caribbean. And I managed to persuade New Scientist to send me there in 1998 to see a total eclipse. Because there was going to be one in England the year after. So I said, why don't you send me to the one before? And so I went there, and unfortunately, so I got this free holiday in the Caribbean. Unfortunately, my wife got ill at Heathrow Airport and couldn't get on the aeroplane. And so her dad had to come and pick her up, and I went on my own. But I met Hovert there, this Dutch, he was covering it for a Dutch newspaper. Anyway, a few years ago, he does Twitter, like me, and he's often get asked, because he knows about astronomy, he gets asked questions on astronomy, and he got fed up answering the same questions. So he would do these Twitter courses. He would say, well, at 6 o'clock, Dutch time, I'm going to do a subject like gravity, and I'm going to do 12 tweets on gravity or something. And these were very popular. And the Dutch newspaper said, we'll run it as a column. So they ran it as a column, and it was very successful. And then he emailed me and said, do you want to do it? I'd like to do an English language version. So I said, that sounds interesting. And so we did. But it was a lot more hard work than I thought. Because if you want to do a subject in 12 tweets, you've got to tell a story from beginning to end. There's got to be a narrative. It's got to be interesting, informative, humorous, and each tweet's got to be less than 140 characters. And I spent more time reducing my tweets below 140 characters than I did anything else. But it's a bizarre thing because, the essence of Twitter is that it's actually a computer thing. It's a digital thing. So to put it on a book is an odd thing. So originally, something starts as tweets, Hovert starts tweeting, it then becomes a conventional book, and then to actually publicise it, we used to tweet some of the tweet courses, so it's really bizarre. The digital world is incredible. I got asked, you mentioned my my app, Solar System for iPad, and my publisher is Faber in Britain. It's a kind of the last major independent publisher. And T.S. Eliot started it, and it has all these people, literary writers like Seamus Heaney, it published. But they're quite interested in new things, and they knew that the iPad was coming out, and they said to me, we'd like to do an iPad app on one of my books. And I said, yeah, that sounds good. But they had no expertise, and they Googled, and they found a company called TouchPress that had done an app that was used in Apple's ads. And anyway, we ended up doing a sequel to it called Solar System for iPad. Which is a digital book, and then because not everyone had an iPad, we end up doing a book. So here, normally you go from a conventional book to digital. Here we went from digital to a conventional book. So it's a really fluid world, the digital world. Yeah. And my publisher is quite interesting. They've done things like a T.S. Eliot app, and they've done all kinds of things. But basically, they've realised that what they're interested into is telling interesting stories. And the vehicle doesn't really matter, whether it's a phone app or a conventional book or an e-book, it doesn't matter. You've just got to tell an interesting story. So they're an interesting publisher. I love them.
So I want to talk about this latest book. While your earlier books did draw on your own specialist knowledge, in this one you really branched out. And there's a lot of biological sciences in here, and you've also talked about money and capitalism. How did you go about researching this?
Yeah, well, first of all, I should say that this wasn't my idea. I have a fantastic editor at Faber called Neil Belton. He's so fantastic that I'm his stalker. When I originally wanted to write a book and I wrote to publishers and they all rejected me, Neil said to me, he was at Random House, and he said, do it, why don't you come and do it? And I met him, and I pursued him from publisher to publisher It looks like I'm a troublemaker who keeps changing publishers, but I follow Neil. And he's a very unusual editor in that many books that wouldn't exist because of him. In fact, many bestsellers exist because of him that have other people's names on. You know, he's that good. And he had lunch with me and he said, what you do is you take complex physics and you try and explain it to anyone. My audience is my wife, who is a nurse and doesn't have any science background, so I'll try and make it accessible to her. So when she reaches for the TV remote control and looks bored, I have to start again. So he said, what you do is you explain complex physics to anyone. Why don't you try explaining everything to anyone? And I was completely daunted and thought, this is ridiculous. How can I do this? So I tried to put him off for 2 years. I tried writing outlines. I thought, well, how can you organise material? You know, and I wrote outlines and I ripped them up. But then I did the app, the Solar System for iPad, and it was all done in a hurry. It was a big team of people. I mean, it's a brilliant app, and I can say that because I didn't create any of the graphics or anything. I've got no idea how it was done. But a lot of people worked on it. Where was I talking about?
Talking about this.
We only had, I had to write 120 stories about planets and moons and asteroids and comets, and we only had 9 weeks to do it in. And so there was no choice but to just jump in, write about things that I knew about. And while I was writing them, thinking, what should I research next? And so that gave me the confidence to just jump in. And so I thought, well, I'll do is I'll start off with things I know nothing about. I don't know anything about money. I don't know anything about the brain. I don't know anything about cell biology. And what I'll do as a journalist is I'll identify people who know, and I'll phone them up and I'll pick their brains. And I had the confidence to do that because when I do physics, I know that if I phone up a physicist, I can speak their language. There's probably a 95% chance they'll be able to answer my questions. If they hadn't thought of my questions, they'll have a go at answering it. But doing it with people in fields that you don't know is really hard. I mean, you need advice, like who should I go to? And then, for instance, like economics, I had to go to 4 people, I mean, I would talk to someone, but I just couldn't get them to speak a language that I could understand, Yeah. And then these people tend to be quite well known, so, setting up an interview with another person takes a couple of weeks, and then you get a sinking feeling that, that you can't understand them again until you find someone. With finance, I mean, I've talked to a guy who was very good called Ha-Joon Chang, who's a Korean. He's a professor at Cambridge, and he wrote a book called 23 Things They Don't Tell You About Capitalism. He was brilliant. For human evolution, I was very lucky. A guy called Chris Stringer, he's a professor of paleoanthropology at Natural History Museum in London. He was brilliant. So I would have done more subjects that I knew nothing about, but it was very time consuming and I had a deadline. Yeah. So I would say it was very hard but very exhilarating to suddenly learn about something that you knew nothing about. And of course my book really is skewed towards things that I do know about, simply because I had to meet this deadline. I got so stressed that at the end that the publisher, the managing director of Faber, took me out to lunch to celebrate me finishing my book. But I hadn't finished it. So that really stressed me.
So in the book you quote a lot of people, ranging from Richard Dawkins, Douglas Adams, Emily Dickinson, and A.A. Milne. So I was curious, is this a reflection of the sort of books you read, or do you have one of those really awesome books of quotes?
A combination. It's a combination. I mean, very often, I would pick I should say, no, I've read all of those books. And I have read many of them. I mean, I really read a lot of fiction.
Yeah. What do you read? What do you like?
Well, actually, incredibly, I just met one of my novelist heroes, actually, Elizabeth Knox, who lives in Wellington. And she started, I loved her book, The Vintner's Luck, which is a love triangle between a woman, a bisexual man, and an angel in early 19th century Burgundy. And it's the most fantastic book. And when I was doing Twitter, Elizabeth started following me. And I was so excited. I went to my wife and said, Elizabeth Knox is following me. I thought, why is she following me? I mean, and I tweeted, my hero is following me. And she never responded. But she retweeted things of mine. And her books are quite amazing and quite weird. And my wife and I, we went to the Adelaide Writers' Festival, and we thought, she's going to be really scary, But she's lovely. She's really, really lovely. So I used a lot of, I collect quotes and things like that that are apt. But then I would do a subject that I didn't know about, like the brain, and I would maybe Google and try and find things that really got things in a nutshell. I spend a lot of time trying to find humorous things and things that really, really pin down an idea.
Yeah. And talking about humour, you have done some stand-up comedy and a comedy TV show. Was it comedy about science specifically?
Yeah, comedy about science.
Is science funny?
I think it can be funny.
Yeah.
Yeah, and one of the problems with science is a lot of people are scared of science. I mean, children are not scared of science; they're not scared of anything, But adults get quite scared about it. So I think if you joke about it, and people laugh, you've gone under their defences. And I do think that with comedy. Most of comedy, just like most of literature, is about everyday life. But there's this huge continent of information, which is ripe for comedy. But it all came about because of a British comedian called Robin Ince, who does these kind of variety nights at the Bloomsbury Theatre in London. And he gets comedians, and he gets musicians, and he gets scientists, and they all do look at like a 10-minute turn. And it's chaotic, and somehow it works. But the programme you're talking about is It's Only a Theory, which was on the BBC, which I absolutely loved. And it was a comedian called Andy Hamilton and Reginald D. Hunter, who's an American comedian. And they would just grill somebody who came on. So I would talk about the Big Bang, and they might get someone talking about evolution. And it was really an informative programme. They had no science background, but they were just interested. And so the jokes were not they weren't essential, but it was just, I enjoyed doing it anyway.
Yeah. In your interview with David Hill and The Listener, you said about your own books that the important thing is to infect someone with a real interest to find out more. So what was it that forged your own interest in science?
My own interest in science? Well, I grew up in a suburb of London, North London. I grew up in Margaret Thatcher's constituency, and my mum and dad left school when they were 15. They'd grown up. They were children during the Second World War, so my mother was bombed out. They didn't get any schooling really because all the young teachers went away to war. So, but they obviously knew the value of education. And my dad bought me a book about astronomy when I was about 8. It was called Dr. H.C. King's Book of Astronomy, and he was the director of the London Planetarium. And I don't know why, but blew my mind, I don't know. No one else in my family has any interest in astronomy or science. And then later, I'm giving away my age now, my dad would get me up to see the moon landings, when I was about 9, and I would see all those fuzzy black and white pictures on the television. And I mean, even talking about it now sends a shiver down my spine. It was that exciting, to see a human being step on another world. And to be alive when that happened, I think, the previous most significant event in the history of life was when, fish crawled out onto the land, and I just cannot believe that I was lucky enough to be alive when that actually happened. Yeah. So I don't know. And my dad died 15 years ago. He's my greatest fan. I don't know why he did that. He must have had some latent interest, and it's too late to ask him now. But I don't know. My dad was my greatest fan. I should tell you that once a friend of mine won a book prize, and my dad said, "You should have won that book prize." And I said, "Well, I didn't enter it, Dad." And he said, "No, you should have won it." And I said, "Well, I haven't written a book, Dad." and he just said, No, he shouldn't have won it. You should have got it. And he just went on and on and on. And my wife and I, we were just laughing so much. And we had to leave, actually. But now I just think how amazing that my dad had that much faith in me that he thought I could win a book prize, having never entered entered it and never written a book. That's faith.
So, in terms of writing books, you've written a book about everything now. So where do you go from there? What's your next book?
I'm going to be a bus driver. Well, I mean, obviously, it isn't really a book about everything. It's about a book about everything, volume 1.
Okay.
Yeah. I mean, I don't intend to write anymore. I didn't really. I don't know what to do next. I've written children's fiction, as you mentioned, which I really enjoyed, and I'd like to write more fiction. That would be good.
Really?
Yeah. But the good thing about popular science is that you will get an advance for it. I've got a reasonable reputation now. People do buy my books. I like science, so and I like it. And it's an incredible feeling when you give a talk and someone comes up to you and they say, I went to university to do physics because my teacher gave me your book and it switched you up. And that's fantastic. I mean, I have this fan called Pam, and she's the wife of a London taxi driver, and she was in her 40s, she's got 3 children, and she wrote to me about one of my books. It's called The Magic Furnace, which is about the origin of atoms, and she said, I was brought to tears by the end of chapter 2 of your book. And I thought, I hope it wasn't the thought of having to read chapter 3. But anyway, to cut a long story short, she was inspired. She'd left school when she was 14. I don't know how you managed to do that because the leaving age, even in my lifetime, has been 15. But she left school when she was 14 without any qualifications. And my book inspired her to get educated and go to university, and she got a first-class degree and everything. She was like, have you ever seen that film, Educating Rita? She was like a real-life Educating Rita. Yeah. And that's so, I mean, she got it. She got this degree, even though her brother had a brain hemorrhage, her son got meningitis on a ski trip to Switzerland, and her husband came down with clinical depression, and she still managed it. And you just think, God, there's so many people out there who are underutilised, and they're like kegs of gunpowder, just need someone to light the match, and I kind of lit the match. I mean, and that's just fantastic. My wife is a Macmillan nurse, so she deals with people who are dying, and if you control their symptoms, you make an enormous difference to their life. They can take their children to Disneyland or whatever, And I never thought that actually science writing could make a difference to anyone's life, but incredibly it can. And that's the most amazing thing. And it's not getting reviews or anything like that. It's that someone comes up to you and they say, you made a difference to my life, which is humbling, really.